Okay, so let's consider this example here. The testing the convergence of the alternating series minus 1 to the k, ln of k over k. So first thing is k is bigger than 2, ln is positive, and so is k. Ln of 2, you can real quickly check, that's 0.69. As long as you're looking at ln of numbers bigger than 1, you're going to be positive. If you're looking at numbers that are smaller than 1, between 1 and 0, it's going to be negative. So it is a positive. This is a positive terms, ln of k over k. So we could again check to see if it's non-decreasing, but I'm going to worry about that later. First, I'm going to check and see, does the series, does the underlying sequence go to 0? Because then I'll worry about whether or not this is a non-increasing sequence. So we'll check that one first. So ln k over k. This would be, of course, an infinity over infinity limit. So we can apply L'Hopital's rule. Limit as k goes to infinity. That would be 1 over k over the derivative of k. And so this does go to 0. This does go to 0. So then we do come to the question, is it a non-increasing sequence? Is it a non-increasing sequence? Well, you could look at this two ways. Think about this two ways. As k gets bigger, we know ln of k grows slower than k, because k being a polynomial. So therefore, this is going to always be growing slower, and that's always going to be growing faster, which is going to, by necessity, mean that it's going to have to, actually, beyond some certain point, this can't be increasing, because this guy's growing slower than this guy. So the top is basically kind of settling in at a number. The denominator is getting bigger and bigger and bigger relative to the numerator. So that's going to have to be decreasing at some point. But let's look at it from a calculus point of view. So our function here would be ln of x over x, and compute the derivative using the product rule. That would be bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. So the derivative simplifies to be 1 minus ln of x over x squared. So we say, what's going on with this? Well, as long as ln of x is bigger than 1, this thing will be negative, which is what we need it to be. As long as ln of x is bigger than 1, then we're good to go. Well, ln of x is bigger than 1 as long as the thing we put in the ln is bigger than e to the first power. All right, so as long as the thing we're putting into the ln is bigger than that, 1 minus ln of x will be negative. So specifically, if we put in 3 or larger, that stuff is going to be negative. The rest of that fraction, x squared, is always going to be positive, so this will be less than 0 as long as x is greater than 3. All right. Since we're dealing with the sequence, I'm only worried about the integer value. So actually at x equals 2, this thing is actually increasing. But once we get beyond 3, that will always be decreasing. So therefore it is a decreasing sequence. The limit does go to 0. So therefore this sequence converges. This sequence converges. Okay. So temporarily, for the very first value, it may be increasing a little bit, but after that, it's decreasing. After that, it's decreasing. Okay? So, therefore, beyond a certain point, it is a non-increasing sequence. And so the limit going to zero, it converges.